This video is going to cover how the periodic table can help you figure out electron configuration, and just generally how the periodic table and electron configuration are related. Some of this is going to talk about quantum numbers, so if you need to review quantum numbers and the allowed values for quantum numbers, you should certainly do that before watching this video. So, starting with the first period, when n equals 1, the only allowed values for L is that L can be 0. And if L equals 0, we have an s orbital, right? And there's only one s orbital. It can hold 2 electrons. And these first 2 columns are where we fill the s orbitals. So those first 2 groups are where we fill the s orbitals. So that tells you something about how the periodic table relates to configuration, electron configuration. And we can look at other sections of the periodic table and predict and know what types of orbitals we're going to be filling. So when n equals 2, when we hit the second period, L can be 0 or 1. And if L equals 0, we're filling an s orbital, and we've already talked about where those are. But if L equals 1, now we're filling a p orbital. And there are 3 types of p orbitals that hold 6 electrons, and those 6 electrons are in this section of the periodic table. So this is where we're filling the p orbitals. So the p orbitals are on the far right side of the periodic table. As we move farther down the periodic table, we get to where n equals 3, and if L equals 0, or when n equals 3, L can be 0, 1, or 2, and if L equals 2, now we have 5 types of orbitals. Those 5 orbitals can hold 10 electrons, so we're filling a d orbital, and that's this section of the periodic table. So the transition metals are where we're filling the d orbitals, and then moving further down the periodic table, we get to where L can be 3. When L equals 3, we'll have 7 types of orbitals that hold 14 electrons, so we'll be filling the f elements. So those are the sections of the periodic table that tell you where the electrons are, right? So if it's phosphorus, atomic number 15, we're filling a p orbital, right? And if it's molybdenum, atomic number 42, we're filling a d orbital. Now, the periodic table can also help with the order, the filling orbital of some of those orbitals. So let's get to the s and d order. So when we get to calcium, atomic number 20, right, it's going to be 4s2. The next element on the periodic table is going to come from a d orbital, right? We're filling the d block. And the first quantum number, the first d orbitals, are when n equals 3. So if this is the first row where we fill d orbitals, then that row is the 3d electrons. So we go from 4s to 3d, because that's the first set of d orbitals that we have. And then the same thing happens when we get to the f orbitals. If we go to barium, atomic number 56, it will be 6s2, and then the next element on the periodic table is lanthanum, atomic number 57, right, which is an f block. And the first set of f orbitals that we have available to us are the 4f orbitals, so we go from 6s to 4f. So that helps you predict the order as well if you go back to what you know about quantum numbers in the periodic table. So there you have it. What types of electrons, what orbitals you're filling based on what section of the periodic table you have, and the filling order for some of those orbitals.